Thank you, Arthur, for the warm introduction. I'm Milenko from TU Darmstadt Space Technology, and this will be about the development of our CubeSat communication system based on CCSDS and ECSS standards. So at first, a picture of our group. So we've grown a little bit since then. We are now 60 students. We are entirely students, so we do not belong to any institute. Our mission composes of three things. At first, outreach. We host an open lecture series at our university, which is open to the public and available on YouTube after each session. We do experimental rocket development. In the future, we hope that we can do also liquid rocket engines. And we, of course, try to build our own CubeSat. Our own CubeSat will be entirely open source. Because of budget, we have a 1-unit CubeSat. We wanted to go bigger, but not possible yet. It will be a technology demonstration of a reflector array antenna, which we develop ourselves. And it will be based on ECSS and CCSDS standards regarding software quality and communications. So Arthur gave earlier an introduction to CCSDS and ECSS, so we can skip that. Here's the equivalent with the OSI layers of what he showed earlier. And we are trying to implement the whole protocol stack. So not just the radio frequency and modulation systems, or maybe the synchronization, but the entire stack. And the good thing about the CCSDS standards is when I went through the floor and saw these novel packet protocol, you don't have to think about implementing a new protocol. It's all there. You can take it. It's for free. All these standards you can access. But there's, of course, when standardization comes into play, always the question about user-friendliness. And yeah, if you go through all these standards, you are at least 1,300 pages, which you should read. And even more, there are green books by the CCSDS, which explain a little bit more in detail how to use them. And yeah, it's really a pain. And for one human, it's not possible. So we decided to join Arthur with his LibreCube initiative and do the developments together with him. And at ESA, we have more resources about how to do it because they are the people using them. So there are pros and cons. Everything is for free. The standards are robust, proven, and if you use them, it enables cooperation because it is necessary to cooperate because it's too much just for us to implement them, but it also would make it possible to work together with others and exchange code, which comes to the next point, reusability. So you can use parts of your code on your ground station or on the mission control center or even on the satellite. It is difficult to understand these standards and there's overhead generated, but the CCSDS is aware of that. And for example, I will show later an example with the Unified Space Data Link, they are trying to get rid of a bit of this overhead. And for CubeSats, of course, there are unused functionalities, but you can cut out some of the functionalities and still be conform to the standards, so you don't have to implement everything because you don't want to drive a rover or something like that. So how I got into it was the Summer of Code in Space in 2017. I did the CCSDS frame exchange over radio link in GNU Radio. And yeah, started to play with GNU Radio. This is what it ended up with and shows some of the problems when using GNU Radio. It's for another person, it's impossible to understand what I did. And when I set up my machine again and tried to run it, it was, of course, impossible because there were blocks missing, there were version changes, some functionality changed, but was not documented. So yeah, super. So we come to the problems, not just of GNU Radio, but this slide is mainly for GNU Radio now. There were bugs. The installation is a pain. So there are like 4 to 5 different methods described to install GNU Radio. And it depends on which Ubuntu version, for example, you run, which version of GNU Radio will be installed, and you have very little control of that. And yeah, so it's quite difficult to get it run on a different machine. So afterwards, we worked out some solutions. One of them is using Docker. We started setting up a Docker file for installing GNU Radio to make it easier to deploy. We will not use GNU Radio anymore for packet detection or anything that has to do with the data in the end. We will do this outside of GNU Radio. We will stream a bit stream out with a zero message queue or TCP or something like this and do it in Python externally because it's easier to control. We exchanged our HackRF to a Lime SDR, which is still not perfect, but a lot better. And we try to keep things simple because GNU Radio blocks are often with a functionality you don't want. So this is just a simplified block. This is not working in real life, but to show you that it can be a little easier when you do the data processing outside. So the next step will be to do the synchronization and channel coding. This is on top of the RF modulation systems. It allows error control coding, and we will do Reed-Solomon coding. So there's frame validation, synchronization, and pseudo-randomizing, and everything is written at first in Python, and later on it will be in C++. Earlier I mentioned the unified space data link. This was one of the over 100 pages, and the essence is that there are virtual channels where you can, for example, separate your telemetry data from science data, but merge them into one physical channel. And in the end, you can separate them easily and route them to different servers. So this is what it looks like. We are using Atom IDE and write it in Python. And for all of you who may ask, what is this green stuff over there? It's called documentation. So we will document everything, and we are doing this with Sphinx, with the nice Read the Docs team, which we like very much. And everything is available on GitHub. This is not yet available, but it will be in the next weeks up there. So I already have the data, but the one who built it didn't upload it yet. So yeah, and this is not finished yet, but we wanted to already make the prototypes public so you can see what we're doing and maybe contribute to it. So these are the active prototypes at the moment. Arthur is working on the message abstraction layer. We don't, and we are working from the bottom. So I'm doing radio frequency and modulation systems, and we do the unified space data link and telemetry synchronization and channel coding. So thank you all for your attention. If you have any questions, please ask.
Thank you, Milenko. So, questions? Comments? I'll bring it to you.
Could you tell a little bit more about the HackRF to Lime SDR transitions, some of the things that you found, reasons why, motivations?
Yeah, for me, the main reason is that the HackRF is half duplex, so it will never be possible to use it unless you have 2 of them. The other thing is the hardware reset. You have to do a hardware reset when you change anything. And this would never be possible to run in a ground station for operations, because you would always have, or you have to solder anything on the PCB to reset it every time, and that's stupid. So, yeah.
More questions? Or some feedback? Okay, then I have a question.
That in the back.
Okay, good.
Thank you for making all that open source.
Yeah, no problem.
Okay, maybe for just as a question also to the entire audience. So as you can see, the problem was here that within this project, the initial idea was to put everything into the GNU radio, into the block diagram. So the entire processing, so demodulating the data and getting the frame data, reconstructing the frame. But now I think the focus is more on building a kind of radio replacement,
Yeah,
where you get a
RF
bit stream
front end.
out.
Yeah, so it's more now a RF front end in the software-defined radio, and the data is outside.
So what is the experience from the audience who work with GNU radio? Do you tend to put like all your logic into a block diagram, or do you also at some point make a cut and say this is then data that I feed into other processes that are running either Python scripts or FPGA devices? Who works with GNU radio? Okay.
So for me, I put most or all of my logic into the GNU radio flow graph, but I tend to use message PDUs a lot. So what I do is to say in the decoding chain, extract the message PDU really soon, and then pass it between different blocks which work on message PDUs. So that's more or less as working outside GNU radio with regular Python code. I tend to do it mostly in Python.
Okay, thank you.
I'm coming.
Yeah, exactly. If your data rate is low enough, use PMT messages. And but if it's going higher, the overhead of PMTs is it's very big. So stay out of it. I will go for the GNU radio. It has a very solid background and many blocks that do the job for you. Just build a solid out-of-stream module, release the code, and eventually people will be interested and contribute back.
Okay.
Why going to a custom solution
Okay.
and reinvent the wheel? So I think a bit. You told about installation issues.
Yeah.
Okay, perhaps you haven't spent enough time to learn about the linking issues that GNU Radio has. There are some issues, yes, but you can overcome it.
Okay.
So
yeah, I will
give
it
again a try.
Yeah, I'll try it again.
My personal opinion.
Okay, thank
But
you.
I'm sure he can overcome the problems, but the question is the user, you know, that we have so many, and the deployment of GNU radio is really painful. I think there were some experience, somebody told me yesterday over a beer, all the problems with GNU radio, but maybe now it's fine.
Yes, most of the platforms right now have pre-built packages for GNU radio. So yeah, eventually if you publish your out-of-stream module, perhaps your module become a package too. It is already done for the GR Osmo. In Debian you can find GR Osmo SDR in a package, and many others. So yeah.
Okay.
Yeah, when it's working, I will contribute it.
One more last question, GNU radio, I mean, this is now the time to speak up. Okay. That's one.
It's not a GNU radio one, but what kind of licenses do you use and why? What kind of license for software and for hardware?
That's an excellent question, and I'm prepared for that. We had the discussion in our group, and I also opened it to the Libre Space community. And the solution, I don't know the guys here, Elkos, but I guess he's one of your group, yeah, was to use the GPL version 3 and the open hardware licensed by CERN. And we had a discussion, and we also decided to do a strong copyleft, because we're a non-profit organization, and there's no reason why anyone should use it for their business and not contributing to it. Yeah. So strong copyleft on everything.
Yes, sir. More questions? No? Thank you, Milenko, again.